Hello everyone, today we'll be going to circular motion. This is one of the first topics in Unit 1 Physics. Without further ado, let's go ahead. So first things first, we had discussed linear motion in a previous video where we talked about distance, velocity, acceleration and such. Today we'll be talking about similar quantities but in terms of going in a circle. Now the first thing we'll be talking about is angular displacement. The angular displacement is based on the angle you move to. So let's say we have point A and point B. Point A and point B, and we move from A to B, we go through this angle here. The angular displacement is equal to this angle that we move through. Now it's not measured in degrees, it's measured in radians. If you don't know, 2 pi radians is equal to 360 degrees. I'll explain radians in more detail in another video, but for now, just know that 2 pi radians is equal to 360 degrees. Okay, so now we're going to talk about angular velocity. Now, just like how regular velocity equal displacement over time, angular velocity, commonly referred to by not a W but a common omega, is the angular displacement or the angle it moves through in a shared unit of time. So that's the angular velocity. Now aside from angular velocity, there's also instantaneous velocity or the speed, normally represented by v. Since I already have v here, I'm just going to erase this. Instantaneous velocity is typically represented by v, and it is the arc length that I represent using L over time. Now, the arc length is the distance on the circumference that was moved. So this length here is the arc length over time. What you should know is that arc length is equal to r theta. And this formula here only holds up when theta is in radians. If it's in degrees, then this formula will not work. So the speed is equal to arc length over t. So we can rewrite it as v is equal to r theta over t. And now we can go ahead, and since we know that omega is equal to theta over t, then we know that v is equal to omega r, or r omega. So the instantaneous velocity is equal to the radius times the angular velocity. And as you know, the unit will still be meters per second. Now, of course, there is a force acting on this. For it to be moving, there has to be a force acting on it, and so that force is known as centripetal force. This is the force that acts towards the center of a circle when a body is moving through circular motion. So anybody moving through circular motion is being acted upon by a centripetal force that's always acting towards the center. And according to Newton's law, F equals ma. Now, of course, the body must have a mass, and so for it to have a force, it must also have an acceleration. That is known as centripetal acceleration. Now, note, a body could be moving at the same speed, at a constant speed around the circle, but its velocity is always changing. Because velocity is a vector quantity, as it changes direction, as you move around the circle, it constantly changes direction, its velocity changes, giving it an acceleration. So this centripetal acceleration that causes the force is equivalent to omega squared r. And so it's equal to the angular velocity multiplied by the radius. It is also equal to the instantaneous velocity divided by r. So these are the formulas you need to know for circular motion. That's basically the concept. Now note there is another force acting on the circle known as the centrifugal force. But that force is a bit more complicated, so we'll go through that at a different time. But essentially, it's just the force acting opposite to the centripetal force. That's all for this video. See you next time.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.